This is a physics lesson about Newton's laws. All three of them. Part 1! Newton's first law. Newton's first law. Okay. Newton's first law says every action, an object in motion remains in motion unless acted upon by an unbalanced force, and an object at rest remains at rest unless acted upon by an unbalanced force. What does that mean? What does that mean? It means that when I roll this tape, okay, it's gonna keep rolling until any forces act on it, which of course there are forces acting on it. Gravity is acting on it. The normal force from this wooden platform is acting on it. The friction from the carpet is acting on it. So it's gonna stop. If there were no forces acting on this tape, it would continue to roll until forever. So that's how that works. Newton's first law is also known as the law of inertia. This car accident, as you can see, where this car flips over, is all about how the car wants to continue to go forward. And even though the person turned, the car still flipped over. Wow, that's pretty cool. Okay, next law. Newton's second law. The acceleration of an object is inversely proportional to the mass and directly proportional to the magnitude of the net force, and is in the same direction as the net force. Translation: the harder you push on an object, the faster it's going to go. And the heavier the object is, the more it will resist acceleration. So it's going to be harder to push it. Yes, the equation for Newton's second law is F equals ma, which means force equals mass times acceleration. You get how much effort you need to push something by multiplying how fast you have to go by how heavy the object is. In this example, this guy is pushing a heavy box. You can tell it's Newton's second law because he has to push with a certain force to get the box to move a certain acceleration, and the box is a certain mass. Wow, that was pretty sick. Okay. Part 3, Newton's third law. Newton's third law. Every action has an equal and opposite reaction. Basically, if you collide two things, they're going to have different reactions because of the two opposing forces. Take, for instance, this tape. When I take this tape and throw it across the room, it has an opposing force. I push on the tape, that's the action force. The reaction force is the tape is pushed all the way out there. That's what happens when you throw something. In this example, two cars crash into each other. You can notice that both cars, although they were the same mass, they had an equal and opposite reaction. Both cars pushed on each other with the exact same amount of force. That's pretty cool. All right. Thank you for joining us. This was how Newton's laws work. Please don't come back.